Hello everyone. Now we are starting your unit 3 and chapter number 1 is data link control. So services provided to network layer by the data link layer. That is first point. Network layer is the layer above the data link layer in the OSI model. So it is supposed to provide services to the network layer. The main service to be provided is to transfer the data from network layer on the sending machine to the network layer of the receiving machine. The virtual path followed for the such a communication is not an actual path. The actual path followed by the data from sending machine to the destination machine, which is via all layer below the network layer, then the physical medium layer, and that's of receiving machine. However, it is always easier to think that the communication is taking place through the data link layer using a data link layer protocol. So there are three types of services that are provided by the data link layer to the network layer. First is unacknowledged connectionless service, acknowledged connectionless service, and acknowledged connection oriented service. So first is unacknowledged connectionless service. In this type of service, the destination machine does not send back any acknowledgement after receiving frame. It is a connectionless service, so no connection is established before the communication and release after it is over. If a frame is lost due to the channel noise, then there are no attempts made to recover it. So this service is suitable only if the error rate is low. It is suitable for real-time traffic such as speech. This type of service is highly unreliable. Second is acknowledged connectionless service. This is next step to improve reliability. In this service, there are no connections established for data transfer, but each frame received, the receiver sends an acknowledgement to the sender. If a frame is not received within some specified time, it is assumed to be lost and sender will retransmit it. This service is suitable for communication over unreliable channels such as wireless channel. And last type of service is acknowledged connection oriented service. This is the most sophisticated service. The source and destination machine establish a connection before transferring the data. A specific number is given to each frame being sent, and the data link layer guarantees that each transmit frame is received. All the frames are guaranteed to be received in the same order as the order transmission. Each received frame will be acknowledged individually by the destination machine. The data transfer takes place by the following three distinct phases. First is connection is established, then the data frames are actually transmitted, and lastly the connection is released after completion of data transfer. Next point is framing. The bit to be transmitted is first broken into the discrete frame at the data link layer. In order to guarantee the bit stream is error-free, the checksum of each frame is computed. When a frame is received, the data link layer recomputes the checksum. If the different from the checksum present in the frame, then the data link layer knows an error has occurred. It then discards the bad frame and sends back a request for retransmission. Breaking the bit stream into the frame is called as a framing. One way of doing this by inserting time gap between the frames. But practically the framing techniques does not work satisfactorily because the network generally do not make any guarantee about the timing. So the some other methods are derived. Framing methods. There are 4 framing methods that are carrying out the framing technique. First is character count method. Second is starting and ending characters with the character stuffing. Third is starting and ending flag with the bit stuffing. And last is physical layer coding violation. So first is character count. In this method, a field of header is used to specify the number of characters in the frame. This number helps to receiver to know the exact number of characters present in the frame following the count. The two frames contains 3 and 8 characters respectively are transmitted over a network. That is an example. The disadvantage of method is an error can change the character count itself. If the wrong character count number is received due to the error, then the receiver will get out of synchronization and will not be able to locate the start of the next frame. The character count method is rarely used in practice. Next method is starting and ending character with character stuffing. The problem of character count method is resolved here by using the starting character before the starting of each frame and ending character of the end of each frame. Each frame is preceded by the transmission of ASCII character sequence DLE STX. DLE stands for data link escape and STX is start of text. After each frame, the ASCII character sequence DLE ETX is transmitted. The DLE stands for data link escape and ETX stands for end of text. So if the receiver loses the synchronization, it just had a search for DLE STX or DLE ETX characters to return back on track. Next method is character stuffing. The problem with this system is that characters DLE STX or DLE ETX can be part of data as well. If so, they are misinterpreted by the receiver as the start of end of frame. This problem is solved by using technique called character stuffing, which is the data link layer at the sending end inserts the ASCII DLE character just before each accidental DLE character in the data being transmitted. The data link layer at the receiving end will remove this DLE character before retransmitting the data to the network layer. Thus, the DLE STX or DLE ETX used for the framing purpose can be distinguished from the one data because DLE is the data always appear more than once. This is called character stuffing. Note that at the receiving end, the destuffing is essential. Destuffing process is exactly opposite to the character stuffing process. Disadvantage of this method is the frame we have used the 8-bit character and ASCII code. The problem can overcome by using next framing technique, that is starting and ending flags with bit stuffing. This technique allows the frames to contain an arbitrary number of bits and codes different from the ASCII code. In this framing technique, at the beginning and end of each frame, a specific bit pattern called flag byte is transmitted by the sending station. Since there are 6 consecutive ones in the flag byte, a technique is called bit stuffing, which is similar to the character stuffing. The bit stuffing is the sender data link detects the presence of 5 consecutive ones in the data stream. It automatically stuffs a 0 bit into the outgoing bit stream. Thus, the 6 consecutive ones will never appear in the data stream. Hence, there is no chance of misinterpretation. This is called as a bit stuffing. Next technique is physical layer coding violation. This method of framing is applicable only to those networks in the encoding on the physical medium contains some redundancy. Some LANs encode each bit of data using 2 physical bits. For example, the use of Manchester coding, the physical Manchester code makes the traditional middle of bit interval. Therefore, 1 bit is encoded into the 10 pairs and 0 bit is encoded into 01 pair as shown. This helps the recognizing boundaries of bit and precise manner. Therefore, use of invalid physical code is a part of 802 LAN standards. The many data link protocols use a combination of character count technique, which is one of other techniques, so they have extra safety. Frame synchronization is the data transmission from source to destination machine is the serial form. Due to the error occurring in the bit during transmission, due to the factors like noise and others, the start bit and the end bit or start frame or the end frame may not recognize by the receiver properly. The receiver may lose the synchronization with the transmission if the transmission sends a long stream of bits or if no steps are taken to synchronize the transmitter and receiver. Serial transmission occurs only following two ways. First is asynchronous frame format and second is synchronous frame format. Next is error control. The next problem to be deal with it is to make sure that all frames are eventually delivered to the network layer at the destination in proper order. Generally, the receiver sends back some feedback, positive or negative feedback, to convey the information about whether it has received the frame or not. A positive acknowledgement ACK indicates a successful error-free delivery of a frame, whereas the negative acknowledgement NAK means that something has gone wrong and particular frame need to be retransmitted. Due to the presence of noise burst, a frame may vanish completely. So the receiver does not receive anything, it does not react at all. That is no acknowledgement. This problem is overcome by introducing a timer in data link layer. Its functions of timers are as follows. As soon as the sender transmits a frame, it also starts a data link timer. The timer timing is set by taking into account the factors such as time required for the framing to react the destination processing time at the destination end and the time required for the acknowledgement to return back. Normally, the frame is received correctly and the acknowledgement will return back to the sender before the timer runs out. This shows that the frame has been received at the receiving end and the timer is cancelled. But if the frame is lost or acknowledgement is lost, then the timer will go off. This will alert the sender that there is some problem. The solution of this problem is that sender retransmit the same frame. But when the frame is transmitted multiple times, there is possibility that the receiver will receive the same frame two or more times and pass it to the network layer more than once. This is called as a duplication. To avoid this, each outgoing frame is assigned to distinct sequence that will help to receive the distinguished retransmission. Next is flow control. This is another important design issue related to the data link layer. In flow control, the problem to be handled is what to do with the sender computer wants to send data at the faster rate than the capacity of the receiver to receive them. This happens when the sender using the faster computer than the receiver. The data sent at a very fast rate will completely overwhelm the receiver. The receiver will keep losing some of frames simply because they are arriving too quickly. The solution of this problem introduce the flow control. The flow control will control the rate of frame transmitted to the value which can be handled by the receiver. It requires some kind of feedback mechanism for the receiving to the sender so as to adjust the sending rate automatically. We are going to discuss some flow control techniques based on this principle. It is a set of procedure that tells the senders how much data it transmits before it must wait for acknowledgement for the receiving. Otherwise, there will be overflow of the data. The data flow should not be so fast that the receiver is overwhelmed. The speed of processing of any receiving device is limited and it has also limited amount of memory storage space for storing the incoming data. There has to be some system for reverse communication from the receiver to transmit the receiver that tells the transmitter about the adjustment of data flow rate to suit the speed to even stop it temporarily. As the rate of processing at the receiving is generally slower than the rate of transmission, each receiver has a finite memory is called buffer. Buffer is a short memory that is saving the transmitted data temporarily. The incoming data is first stored into buffer and then sequentially processed. If the buffer begins to fill up, the receiver must be able to tell the sender to stop the transmission until the buffer gets empty. Similarly, the transmission also has a buffer for storing the bits if the transmission is stopped. Next is elementary data link protocol. There are four elementary data link protocol: an unrestricted simplex protocol, a simple stop and wait protocol, a simplex protocol for noise channel, and piggybacking. So first is and unrestricted simplex protocol. This protocol is the simplest possible protocol. The transmission of data takes place only in one direction, so it is simplex, that is unidirectional protocol. It is assumed that the network layer of the sender and receiver are always ready. It also assumes that we can ignore the process time if the buffer space is available infinite. The communication channel is imagined to be noise free, so it does not damage or lose any frames. All this is higher unrealistic. This protocol is also called as utopia. Utopia, that is UTOPIA. Utopia. This protocol consists of two distinct procedures, namely sender and a receiver procedure. They runs into data link layer of their respective machine. No sequence or acknowledgements are used in this protocol. Second is a simplex stop and wait protocol. The most unrealistic restriction in the previous protocol is assumption that the receiver network layers can process the data with zero processing time. In this simplex stop and wait protocol, it is assumed that the finite process time is essential. However, the like of first protocol, the communication channel is assumed to noise free and the communication is simplex, that is only in one directional or unidirectional at a given time. The protocol deals with an important problem, that is how to prevent the sender from flooding the receiver due to the data rates faster than the processing speed of the receiver. In this protocol, a small dummy frame is sent back to the receiver and the transmitter indicates that it can send the next frame. The small dummy frame is called as a acknowledgement. The transmitter send a frame, then waits for the dummy frame called the acknowledgement. Once for the acknowledgement is received, it sends the next frame and wait for the acknowledgement. Hence, the protocol is called as a stop and wait protocol. The best thing about this protocol is that incoming frame is always an acknowledgement frame. It need not to be evenly checked. Next is a simplex protocol for noisy channel. This is the third protocol in which we can go one step ahead, assume that the communication channel is noisy and it can introduce the error while data traveling over it. The channel noise can either damage frames or they may get lost completely. In this protocol, the sender waits for the positive acknowledgement before advancing to the next data item. There is a timer set at the sender when the frame is sent. If the sender times out, it resend the same frame again. So it is called as a PAR, that is positive acknowledgement with retransmission, or automatic repeat request, that is ARQ type protocol. If the frame is badly damaged or lost, then the sender would retransmit it. Note that due to the retransmission time out of any other reason, there is always possibility of duplication of frame at the receiver. To avoid this, the sender puts a sequence number in the header and of each frame sent. The receiver can check the sequence number of arriving a frame to check the possible duplicate frame. If a frame is duplicate, then receiver will discard it. The operation can be divided into two modes. First is normal operation and second is timeout. Normal operation is after transmission one frame, the sender waits for the acknowledgement from the receiver before transmitting the next one. In this way, the sender can recognize the previous packet is transmitted successfully, and we could say stop and wait guarantees reliable transmission between the nodes. To support this feature, the sender keeps a record of each frame it sends. Also, to avoid the confusion caused by the delay or duplicate ACKs, stop and wait sends each packet with the unique sequence number and receives the number in each ACK, that is in each acknowledgement. And second is timeout. If the sender does not receive ACK for previous sent frame after a certain period of time, the sender timeout and retransmit the frame again. There are two causes when the sender does not receive the acknowledgement. One is the acknowledgement is lost, and the other one when the frame itself does not receive, that is it got lost. There are two possible cases. that are, to suppose this feature, the sender keeps the timer for each frame, and we have already discussed the timer is introduced in the data link layer. Next elementary data link protocol is piggybacking. In the all practice situation, the transmission of data needs to be bidirectional. This is called as a full duplex transmission. One way of achieving full duplex transmission is to have the separate channel, one for forward data transmission and other for reverse data transmission, that is for acknowledgement. But this will waste the bandwidth of reversal channel almost entirely. The better solution would be each channel, forward and receive, to transmit the frame in both directions with both channel having the same capacity. Let the A and B the user, then the data from A to B and intermixed with the acknowledgement from A to B. By checking the kind of fields in the header of receive frame, the receive frame can be identified as either data frame or acknowledgement frame. One more improvement can be made. When the data frame arrives, the receiver wait does not send the control frame, that is acknowledgement frame, back immediately. The receiver waits until its network layer passes the next data packet. The acknowledgement is then attached to this outgoing data frame. Thus, the acknowledgement travels along with the next data frame. This technique, in which outgoing acknowledgement is delayed temporarily, is called as a piggybacking. Advantage of piggybacking is better use of available channel bandwidth. This happens because of acknowledgement frame need not be sent separately. And disadvantage of piggybacking is the additional complexity. If the data link layer waits too long before the transmission of acknowledgement, then the retransmission of frame would be takes place. Next protocol is sliding window protocol. This is most robust and the bidirectional protocol. All the protocols are specially types of protocol called as a sliding window protocol. They show different performance in terms of their efficiency, complexity, and buffer requirement. Sequence number. One important feature of this sliding window protocol is each outbound frame contains a sequence number ranging from 0 to some maximum value. The maximum value generally equals to the 2 raised to n minus 1. The value of n can be arbitrary. Sliding window protocol are basically the imaginary boxes at the transmitter and receiver. This window holds the frames at the transmitting as well as receiving end, and provides upper limit on the number of frames that can be transmitted before acknowledgement is obtained. So in the short, we can say that at any instance of time, the sender maintains a set of sequence numbers corresponding to the frames it is permitted to send. This frame which are being permitted to send are said to residing inside the sending window. The receiver also maintains a receiver window. It corresponds to the set of frames that receiver is permanent to accept. The sender and receiver window can be different in size. The positive and negative acknowledgement, that is ACK and NIK, should be used after every frame. That means the sender sends a frame, wait for acknowledgement, and then next sends to next frame or retransmit the original one. Only after receiving either positive or negative acknowledgement from the receiver. In order to improve the efficiency, the sender sends multiple frames at a time. The receiver checks the CRC for the frame one by one and sends one acknowledgement for all the frames. This is the principle of operation of sliding window technique. In this technique, an imaginary window consists of n number of data frames are defined. This means up to n number of frames can be sent before receiving an acknowledgement. This is known as sliding window because window can slide over the data buffer to be sent. We have studied the sliding window. This means the sender can send n number of frames at a time and then wait for the acknowledgement for the receiver. For example, the frame size n is equal to 4. That means the sender can send 4 frames at a time and then wait for the acknowledgement from the receiver. So there will be one acknowledgement corresponding to the 4 frames that are sending over the network. Next is a 1-bit sliding window protocol. This protocol is called as a 1-bit because the maximum window size, that is equal to 1. It uses a stop and wait technique which have discussed previously. The sender sends one frame and waits to get it acknowledgement, and sender transmit the next frame only after receiving the acknowledgement of earlier frame. So 1-bit sliding window protocol is also called as a stop and wait protocol. The sequence of event taking place when a frame is transmitted and receiver is: the data link layer of sending machine fetches the first packet from the network layer, then it builds the frame for it and sends to the receiver. Then the receiver data link layer checks the received frame for the duplication, and last is if it is okay, then it passes the frame to the network layer. Next is a protocol using go back and N. Go back N. In this stop and wait protocol, it has assumed that the transmission time received for the frame to arrive at the receiver plus transmission time for the acknowledgement to come back is negligible. But in some practice situation, this assumption is not correct. In this system, like satellite system, the round trip time can be as long as 500 milliseconds propagation delay. This will reduce the efficiency of the protocol. Therefore, an improved protocol known as go back N ARQ has been developed. It is method used to overcome the inefficiency of the stop and wait ARQ by allowing the transmitter to continue the sending in a frame so that the channel is kept busy while transmitting wait for the acknowledgements. In this method, if one frame is damaged or lost, all frames are sent since the last frame acknowledged and retransmit. The principle of go back and N is: the major difference between this and previous system is that sender does not wait for the ACK signal for transmission of next frame. It retransmits the frame continuously as long as it does not receive the NAK signal, negative acknowledgement signal. The negative acknowledgement signal is the sent by the receiver to the transmitter. When the receiver detects an error in the third frame, for example, the receiver detects the error in the third frame, the receiver sends NAK signal back to the sender, but this signal takes some time to reach the transmission. By that time, transmitter had transmitted 7 frames. On the reception of NAK signal, the transmitter will retransmit all frames from 3 onwards, and receiver discards all other frames that have received after 3. That is 4 to 7 frames are rejected. It will then receive all the frames that are retransmitted by the transmission. Source of error in the protocol go back N is the error can be introduced if the transmitted frames are damaged or lost, or if the acknowledgement is lost. Let us consider the operation using the protocol under this condition. So the first condition is frame is damaged. Suppose the second data frame is damaged, so the error is detected and received the NAK2 signal back on the receiving signal. The transmission starts the retransmitting from frame 2. All the frames received after the second frame is discarded by the receiver. So second operation is operation when the frame is lost. In this case, the lost frame is also treated as the same manner as of damaged frame. That is, if the second frame is damaged, the receiver sends NAK2 signal back to the transmitter, and then transmitter sends the frame from the second frame to the next frame. Then the receiver will take the second frame and discard all other frames by the sender. Next is operation when acknowledgement is lost.
In case of go back n method, the transmission does not expect the acknowledgement after every data frame. It cannot absent the sequential ACK number of identifying a lost ACK or NAK frame. Instead of it uses a timer. The transmitter can send as many as frame the window allows before waiting an acknowledgement. Once the limit has been reached, on the transmitter has no more frames to transmit, it must wait till the timer goes off and retransmit all data frames again. The disadvantage of go back and ARQ protocol is in the noisy channel. It has poor efficiency because needs to retransmit the frame in the error all subsequent frame. Disadvantages of this go back n protocol is it transmits all the frame if one frame is damaged or lost. Second is it transmits a frame continuously as long as it does not receive the NAK signal. The NAK signal takes some time to reach the sender. Till that time the sender has already sent the some frames. All those will retransmit after receiving the NAK. The errors can get introduced if the NAK is lost. Thank you.